Arhan will join next week. He's busy for some family issues. He is now okay, but his family had some programs. That's why he's busy. He phoned me. He called me and informed me that, and he promised me that he will make up all the things he missing now.
Yes, sir.
And
What about Navid?
Navid should join. He is supposed to join. Let me write the message to him, right? So
Yes, sir.
he can join quickly. Okay, I wrote the message.
Yes, sir.
Okay, now look, read the question two. Read.
A ball of mass m is thrown vertically into the air. When the ball has speed v, the air resistance acting on the ball is F. What is the magnitude of the acceleration of the ball when its speed is v as it rises and as it falls?
Okay. Yeah, find it. Get it.
Yes, sir.
Get it. What is your answer?
Sir, B.
How?
Sir, because that ball of M is thrown vertically into the air. It
Yes.
is vertically acceleration and ball is rising.
Hmm.
So it is vertically.
Hmm.
Marshal, ওই যে সোজা করে একদম উপরে ওঠানো।
Yes.
The
Yes.
air
Yes.
resistance acting on the ball is F.
Yes. Then uh, your
So, sir, for
ball
the
is,
acceleration, I think it
if
should be B.
ball is rising up, then the G is here acceleration due to free fall, right?
Hello,
G is acceleration of
hello.
free fall, right? Hello.
Yes, sir.
G is
Sir, I'm
acceleration of
listening.
free fall.
Free fall.
Yeah, and F by M is the resistance, right? Uh, you are getting F is the resistance of the air, so F by M is the deceleration you are getting from the air resistance, isn't it?
Yes, sir.
So uh, if something is thrown upwards, then air resistance uh, and the acceleration due to gravity, right? Gravitational force, both are working against the motion of the object, right?
Yes, sir.
Yes, sir.
So both are working against the motion of the object. That means both are added, not
Yes, sir.
subtracted, isn't it?
Yes, sir.
Yes, sir.
Both are added. So where we are getting both are added?
D.
In D we are getting, also in C we are getting, right? Like both are added means the acceleration due to gravity that is added, also the deceleration that is added. In that sense, we are saying both are added. Like acceleration when the ball is rising, we are only thinking about the first column now. When the ball is rising, got it, Navid?
Yes, sir.
When the ball is rising, that moment the air resistance is working against the motion, and also gravity is working against the motion, isn't it?
Yes, sir.
Yes, sir. Yes, sir.
So both the forces are working against the motion of the object. That's
Motion.
why that's why the deceleration it will get both from G and both from the air resistance deceleration, right? Isn't it?
Yes,
Yes,
sir.
sir.
So those two values will be added. In C and D, we are getting both the values added. So our answer will be either C or D. Now about the second column, when the ball is falling, you please take notes. This one is very important to understand because here students becomes confused. Ah, when the ball is falling, that time also the air resistance is working, right?
Yes, sir.
Yes, sir.
And the ball is falling, that means is working towards the gravity. So
Yes, sir.
air resistance is working against the motion, but the
Against the gravity.
yeah, but the gravity is working towards the motion of the object, right? So
Yes,
one
sir.
is opposite to another one. That time it will be subtracted.
Yes, sir. So C.
See, is it clear? Take the notes. You got your worksheet printed, right?
Yes, sir.
Yes, sir.
So here I'm giving you the way how to take the notes, worksheet. This way, you make a circle here. Mm, Here make three circles. One circle is here, one circle is here, and one circle is here. Okay. And for this one, first circle, you write, you label here. mm, This way you label arrow. Then you write in text. Both both is working against motion, huh? Okay. Both is
Yes.
working against motion. That's why we are adding them. And for G, this one we'll write what we'll write G for G. For G, we are writing working towards motion, huh? Working
Towards motion.
towards motion. That's why it is in one direction, and another one, this is okay, this one is working against motion. So it's done, right?
Yes, sir.
Question number two, you are clear about this. So Navid, could you please take the no, yeah, snap of it and send it to group?
Okay, sir.
Done, right?
Yes, sir.
So we are going to next question. After two, which one?
Sir, 4.
4.
Four. Question number four. Yeah. Okay, Navid, read it, huh? Question number four.
A resultant force of 10 Newton acts on a body for a time of 2 seconds, which graph could show the variation with time t of the momentum p of the body.
Okay. So what will be the possible answer?
B.
Bangladesh.
Yes, sir. I think.
Yeah.
Sir, I also think that.
Yeah. I also think that. Yeah.
Because sir,
Hello, sir.
I found that the gradient of B, because like gradient is change in y divided by change in x, which is del p by del t, which is equals to
Delta
force, and
force.
I get minus 10 Newton, so which is 10 Newton basically.
Yeah.
So B.
Okay. So B, huh?
Yes, sir.
Correct. You got del P by del T.
Yes, sir.
Del P
Which
by
is
del T. So you got
gradient
gradient
minus 10.
minus 10. Del
Sir,
P,
F is equals to del T by del T.
F equals del P by del T. Yes. Very good. So you are getting 20 by uh,
My
10,
minus 2.
20 by
0 minus 2.
2 minus 0, right?
Uh, Sir, wait.
Hello.
If I take y1
Okay, okay.
20,
Then yes. So at the is gradient is negative, right? That's why you got minus 10, right?
yes,
So
sir.
Minus 10.
yes, it can be. It can be. If there is deceleration, then resultant force can be minus.
Yes,
That's
sir.
great. Yeah. So for other answers, you are not getting that one, right?
Yes,
So
sir.
F equals del P by del T. That is coming minus 10. Okay.
Yes, sir.
And that's matching with the given information, right? So
Yes, sir.
your answer is B, Bangladesh. Correct. Then next, six. Six, though it's not mentioned in the homework list, but it was also
6 we
left.
did, sir.
Six,
6B.
6B, right? How?
Yes,
Yes,
sir.
sir. We did this one.
You did this one. Okay.
In
So,
last class.
yeah. So, what is the formula in your notes?
So,
If the coalition is
sir, M.
perfectly, if the coalition is perfectly elastic, then we have U1 plus U2
Two.
equals V1 plus V2, right?
V1 plus V2. Yes, sir.
So that one, if you apply, then you can also get the answer of this.
Yes, sir.
That table one, this one, 17. We said that 6, if you understand, you can also do 17, right?
17.
Yeah. It is
Yes, sir.
also like that. Like they are saying, which collision is not elastic?
Sir,
So
we left 7.
yeah, we will do that one, but we are here because if you understand 6, then you can also solve 17. One is related
Yes,
to
sir.
another one, so the related things we are doing together. Is it clear?
Yes,
Yes,
sir.
sir.
So the formula just now I told you, U1 plus U2 equals V1 plus V2. That is also applicable for this question. For elastic collision, that one we are getting. So they are asking us which one is not elastic. So for 3, you will get U1 plus U2 equals V1 plus V2. But for the other one, you will not get that. Check from the given value. Check which one is not
Yes, sir.
elastic. You apply that formula U1 plus U2 equals V1 plus V2.
Yes, sir. So 2 minus 5, which is equals to minus 3, is equal to minus 5, minus 2 is minus 7. Sir, first one is minus 3 is equals to minus,
So first one is giving you minus 3 equals to minus 7, right?
minus 7. Yes, sir.
And the other things are matching, right?
Yes, sir.
Yes, sir.
Other things are matching. Those are elastic, and this one is inelastic.
Yes, sir. So A.
A, correct.
Sir, U1 is minus 3 and oh, I got it. So it should be same.
Hmm.
Sir, you heard the news of Elon Musk?
What?
Of Elon Musk. Do you heard the news?
Elon Musk. What
Yes,
news
sir.
that?
আচ্ছা দেখেছেন?
What news? I don't understand what you are saying.
Of Elon Musk. I'm telling that the news of Elon Musk.
Elon Musk.
Yes, Elon
Oh,
Musk.
oh, he's the an entrepreneur.
Yes, sir, entrepreneur.
Yeah. What is that news? I did not see it yet. What this news?
Sir, later on I'll tell you. It will take a big discussion.
Okay, okay. Elon Elon Musk is like Jeff Bezos, right? He's also like one entrepreneur in the you know online business, right?
Yes, sir. He have rocket. He do have SpaceX
Space.
group.
Yeah, yeah.
He do have Tesla.
Yeah,
ছয়টা giant প্রতিষ্ঠানের chairman. He's
yeah.
the chairman of six giant, a very big rich guy. He is now the richest person.
During the Corona time, the persons who became more rich, he is one of them. He, Jeff Bezos, then Mukesh Ambani of India. This guy, they became more rich during the Corona time. Alibaba fall down.
Sir,
Class
Alibaba's
minus.
CEO is missing.
Yeah, Jack Ma, he is missing because he has some conflict with the Chinese government.
Chinese government, yes, sir.
Like they have some, difference in their thinking and application, right? That's why Chinese
Sir.
government is not allowing him to do
Yes,
business.
sir. Communist government.
Yeah. Okay, let it come. We will come back here. So the coalition A is not elastic, right?
Yes, sir.
Correct. Then you understood it, Hassan.
Yes, sir.
You understood. Then we are going to now seven. Yeah, seven. Read. Now read it. Seven.
The diagram shows two identical spheres x and y. Initially, x moves with speed v directly towards y is stationary, the spheres collide elastically. What happens? A. Sir, then- sir, I think it's D.
Okay. Why it is D?
Sir, because they said it's elastic
Initial moves.
co- collision, so
So
the entire kinetic energy will be conserved.
Yeah. So
So
that.
if x stops and y moves with speed v, the is conserved. The kinetic energy is conserved.
Yes. Yes. Correct. So Hassan, you got the same also, right? Question number seven.
yes, sir.
Yeah.
Yeah,
D. The answer is D. Dhaka. Then
yes, sir.
after seven, which one?
Sir, after
11.
seven, is it? Yes,
11.
sir. 11.
Okay. So read 11. Hassan, read 11.
A car is moving at constant speed in a straight line, with the engine providing a driving force equal to the resistive force F. When the engine is switched off, the car is brought to rest in a distance of 100 meters by the resistive force.
Hmm.
It may be assumed that F is constant during the acceleration. The process is then repeated for the same time with the initial speed but with a constant resistive force. How far will the car driving while decelerating? Sir,
Yes. Yes.
sir, I got the answer. It is, sir, I'm getting two types of answer.
Say which types?
Like, sir, one is B, one is D.
One is B, one is D. How B can you say?
So that was the mark scheme.
That was the mark scheme.
No.
Actually, when you are saying any answer, not only say B, D. You should explain. Then you say yes. The answer is this one. If someone is saying you this answer is A or B or C or D, that's not enough, right? You should
Yes, sir.
also have the explanation why it is that one. That will make you confident and you can answer any any question like the same concept, right?
Yes, sir.
Isn't it? So tell us, tell us the explanation how you got B or D.
Sir, first thing is the car is at constant speed. So for the distance is 100 meter by resistive force.
Hmm.
And sir, for deceleration, so F is equals to ma. Hmm.
So this one is not that F. This is resistive force. This is resistive force. So this resistive force is working against the motion, right? And that time
Yes,
you are
sir.
getting deceleration. That deceleration is giving you the resultant force. Okay, and that one is giving you resultant acceleration. And when you are calculating with the distance, you should focus with the resultant acceleration. Okay, so uh, we have here another information that F is constant during the deceleration.
Deceleration.
F means here resistive force. Resistive force is constant during the deceleration. Then we have another information like the process is repeated for the same car with the same initial speed but with a
But
constant
with a
resistive force. That means resistive force is now
0.8.
uh, decreasing, right? Resistive force is now decreasing. So,
Yeah, yeah.
so the deceleration, if your resistive force is now decreasing, then deceleration will happen what? Your deceleration will also decrease, right?
Decrease.
Yeah.
Yes,
So
sir.
if deceleration decrease, then it will go little bit more, right? It will go little
Yeah.
bit more before stopping. So how much it will go, that one we have to take from this information. You have to calculate. You should show numericals. Then you'll get the answer. Hmm.
Oh,
So you
yes,
have
sir.
one information here. You have same initial speed, right? We have
Yes, sir.
same
Same
initial speed.
initial speed.
Yeah. So we have some more information. The distance is given. Then for the first one, it got rest. So from there, you can find deceleration. Hmm. So you write the formula V square equals E square
Plus 2
uh,
AS.
plus 2AS. There you are getting one relationship that is 0 equals
So we
E
have to do
square.
simultaneous equation, right?
Yeah, do it. Do the simultaneous equations. Okay, you do it, huh? Then what is the answer of 12? It is very simple, right?
Yes, sir. Sir, I first did v square is equal to u square plus 2as. V is equal to 0 square, probably.
Mm-hmm.
No,
Or, wait, V.
v
Yes,
square
sir.
is
The
equals to
car
use
is brought to rest.
Mm-hmm. And zero
So, V,
equals.
final velocity would be 0 square
Mm-hmm.
is equal
zero
to
square.
u square minus 2 a. Oh, acceleration I used as force by mass
Mm-hmm. Which one is
into
force?
100.
Which one is force?
Sir, I
The
didn't
force is zero
write.
point 0.8.
Sir, I didn't write the force. I thought I will substitute the a with the second equation.
Okay. Okay. So you are writing that F as the resultant force, right?
Yes, sir.
Not this frictional force, not this
No,
resistive
sir.
force.
Sir,
Okay,
I
so
wrote the resistive force one.
why
The resistive
resistive?
force, I can multiply it in the second equation, right?
Yeah, you do it later. But there is also some relationship with the resultant force and resistive force, right?
So what relationship?
Like you are giving driving force. Uh, your
Yes,
resistive
sir.
force, if you subtract from the driving force, then it's giving you a resultant force. So your driving force minus resistive force is
Yes,
giving
sir.
you resultant force, right?
Yes, sir.
Then you can say your driving force, it is fixed, right? Like initial speed, they are saying initial
Yes,
speed
sir.
is same. At the beginning what speed they had, now also have the same speed, so we can say the driving force is same, right?
Yes,
Only
sir.
what happens, the resistive force, uh, they are saying uh, engine providing a driving force equal to the resistive force F,
Yes, sir.
isn't it? So if it is in constant speed, there is no acceleration at the first one, first case. There is no
So
acceleration.
acceleration would be 0.
Yeah, here acceleration is not there because they say the
So
drive.
0 square is equal to u square plus 0.
Hmm.
So 0, so u square is equal to 0.
So this formula will not be applicable there, right?
Yes,
We
sir.
we don't have used that formula here. Now we should go for other formula. Is there any other formula with distance
Sir,
traveled?
S is equals to UT
As it
plus
is,
half ATs.
yeah, you have constant speed here, right? Constant speed. So we can use the average speed formula, right?
Yes, sir.
That one.
So so S is equal to VT.
Yeah, S equals VT. That one.
But oh, acha, and we don't know the S,
Which one?
and we don't know the S, right?
Here S is given. This one, 100.
Acha, the 100 meter.
Yeah.
100 is S.
So 100 is equal to, we know V square is 0.
No, no. Here they say when the engine is switched off, the car is brought to rest in a distance of 100 meter by the resistive force, right?
Yes, sir.
So
Yes, sir.
this resistive force is working that time, right? So here
Yes, sir.
in this condition we have the starting starting speed is this one, right? Constant speed, that one. For example, it is u. Okay. So in this
Yes, sir.
condition, we have the final velocity 0 and initial velocity is this constant speed, right? Then we can apply that one, resistive force. Okay,
Yes, sir.
do it then. What it comes?
Sir,
Yeah,
can you say the yeah again?
which one?
The last part
Yeah, last
you
part
just said.
is, yeah, last part you say, you see here
The
is
resistive
constant.
force.
Yeah, the resistive force is constant, right? The same
Yes, sir.
resistive force we are using here. So it is, for example, F, right?
Yes, sir.
Yeah. So the resistive force is decelerating, right? Uh, because of
Yes,
this
sir.
resistive force is deceleration. So deceleration is come to rest. That resistive force is giving you the deceleration, right? Isn't it?
Yes, sir.
So you write V F equals ma. You know, right?
Yes, sir.
And you know F equals mv minus mu by t, right?
Yes, sir.
Yes, sir.
Yeah. So you write F into t, right? F into t,
Ft is equal to mu minus mv.
mv minus mu. Yeah. So that
Actually,
one
mv
becomes,
minus mu.
yeah. So 100 meter, how can you relate with that?
I just said the s is equal to vt.
S equals pt. S
So
equals,
100 is equal to, we don't know the time, so t is equal to 100 divided by v. And what will be the value of v?
hmm,
So V should be কি বলবো?
yeah. Try it, Asan.
So v cannot be 0, so the answer will come undefined. But
For this line, you see, for this line, v is 0, right?
yes, sir.
So you can write it here. You try it, huh? Both of you try it, huh? And before going to break, you tell me the answer of 12. Then you
Sir
try your
B.
12
own.
is 12 is a.
Uh, in an elastic collision, momentum is constant. Okay, then what is the statement of the principle of conservation of momentum? In conservation of momentum, what you got?
স্যার এটা তো
So in
প্রোডাক্ট
an
অফ ম্যাস
isolate,
অ্যান্ড ভেলোসিটি।
Yeah,
uh, sir, was that in conservation of momentum?
yeah. In elastic collision, momentum is constant. Also, the kinetic energy is constant, right?
Yes, sir.
Uh, so, in principle of conservation of momentum, we are not getting kinetic energy constant, right?
No, sir.
Look, in all this statement, you cannot say they are wrong. If you think about B, momentum is the product of mass and velocity. This is also right, isn't it?
Yes, sir.
Yeah, then the force acting on a body is proportional to its rate of change of momentum. It is also correct, right? But for conservation of momentum, that means for a system, the momentum will be conserved Uh, for this one, we had a special condition. That one is the system should be isolated system, right?
Yes,
That
sir.
means there is no external forces working on it, isn't it?
Yes,
So,
sir.
so the
Yes, sir.
appropriate answer should be Dhaka. Then come
Okay,
back,
sir.
huh?
Huh?
Come back with the solution of 11. Okay. For 12, the answer is
Okay,
Dhaka.
sir.
Thank you.
Sir. Assalam alaikum.
Walaikum salam.